we are asked to find the slope of the line tangent to the curve. Let's stop right there. We are not asked to find the equation of the tangent line, just the slope. So we need the derivative of this pair of parametric equations, which means we have to find dy dt, and we're going to find dx dt, and we're going to put dy dt over dx dt, and it's going to be that simple. And so we're going to find the derivative of this. That'll be cosine of 4t. Oh my goodness, it's the chain rule. Multiply by 4. And then the derivative of cosine 2t would be negative sine 2t. Oh my goodness, it's the chain rule. There we go. So the derivative, like the derivative, will be dy dx, which is dy dt over dx dt. And again, you could think of the dt's canceling out. Operationally, it's iffy the way we would technically compute that, but it's the same concept. Okay, and I hope you notice it. We can reduce a little bit. No, you can't reduce this 4 and 2, but you can reduce this 4 and 2. So that's going to give me negative 2 cosine of 4t over 1 sine of 2t. And they want us, whoever they is, they want us to compute the actual slope at that t value. So we're going to plug that in. We'll use our knowledge of the unit circle. So dy dx at t equals pi over 4. I'm trying to save some space. I've worked through this one. That one takes a little more space. I should have moved it up some. So negative 2 cosine of 4 pi over 4. You can see where this is going. And sine of 2 pi over 4. And that's going to give me negative 2 cosine of pi divided by sine of pi over 2. All right, sine of pi over 2 is the y value at pi over 2, which is 90 degrees. That would be 1. And negative 2 cosine of pi. Cosine of pi is negative 1. So I have negative 2 times negative 1, which gives me positive 2, and that is indeed positive 2. All right, we have found the slope at this t value. Now let's find the slope at the t value associated with this. Oh boy, okay. So just because I'll need the space, I know I will. I'm looking at my scratch work from previously. I'm gonna draw that just to have some boundaries here, and the sun will shine in its beam of light. So let's switch colors too. I would use purple, but it's almost dead. Let's go to green. Switch to green on this one. Okay, I would like to know the t value associated with this. In order to find a derivative at a value, I need t. Well, I don't know t. They didn't give me t, but I can find it using a little bit of common sense here. So x is square root of 2 over 2, and that is equal to cosine of 2t. And we'll solve that. While we're at it, we'll also talk about the fact that y is 1, and that is equal to sine of 4t. And we'll go from there. Let's jump back to this one. Okay, where is cosine square root of 2 over 2? Where is the first place? I mean, we can think of a couple places where that's the case. This would be pi over 4. And I would love to say that that's equal to t. It's not. It's equal to this, which is 2t, which means that t is equal to pi over 8. Now, hopefully, we're going to get t equals pi over 8 out of this too. So 1 is equal to sine of 4t. Okay, well, where is sine equal to 1? Well, that would be pi over 2. That's equal to 4t. So we're going to divide by 4, and we're going to have pi over 8. Okay, so indeed, we have a couple t values where this matches. So fair enough, we got this. And we will come over here and find the derivative at t over 8. Y dx at pi over 8. T equals pi over 8 is what I meant to say. And it's going to take a little bit of work. So same derivative. I don't have to redo that. We're going to have 4 cosine of 4 times pi over 8 divided by negative 2 sine. Ooh, I'm not using the reduced form. Totally could have done that. Didn't even think about it. Oh well, I was looking here, not here. It works. 2 pi over 8. And we'll just go ahead and jump to that reduced form. So negative 2 let's see, this is cosine of pi over 2. And that is divided out. That's where that negative 2 comes from. Sine of pi over 8. Whoa, pi over 4. Sorry, my fault. Negative 2. Let's see, cosine of pi over 2 is 0. So it really doesn't matter what we get in the denominator, as long as it's not 0, the answer is 0. Now if we had 0 over 0, we'd have a problem. We would not have a smooth curve there. This goes back to the definition of a smooth curve, where we would have both of them simultaneously being 0. That is not the situation. Cosine of pi over 4 is square root of 2 over 2, but we just end up with 0. So the slope at that point would be, well, 0.